Okay, today we're going to talk about vectors. So, vectors. Okay, vectors. Now, vectors are amazing things. Okay, a vector is a line with an arrowhead. Okay, the arrowhead points the direction. So, the important things about vectors is that it has a length, and this is going to be known as its magnitude, and it has a direction, and that's where the arrowhead points. Okay, it has a direction. And typically this direction is with respect to an axis. Okay. So we specify what axis it's on, and then we can determine what that is. And usually it's listed as an angle. Okay. So for instance, we can sit there and we can have a vector here that comes up like this. And we would say that this is at an angle with respect to the x-axis. Here's the x-axis right there. And this angle would be labeled as theta. Okay, so theta equals angle. Okay, and this is a Greek letter, theta, or theta. It depends on how you want to pronounce that. Okay, so here is our magnitude. We have our length here, magnitude, and here we have our direction. Okay, so this is our direction. And that's the thing about vectors, is that they are magnitude and direction, so they can tell us which way that they go. Unlike just having a line segment, which only tells us a distance. Without the angle, okay, whatever this is just going to tell us that there's a circle at that radius somewhere. Okay. All right. Now, the great thing about vectors is that we can add vectors. Okay, so adding vectors. If I have two vectors, let's call them vector A right here, and we'll say that we have a vector B right here, which I will make a bit shorter. Okay, so the blue line and the green line. Vector A here has a length of 1, 2, 3, 4, 5, 6, 7, 8, 9 squares. So we're going to call it a length of 9. Vector B here has 6 squares. So if I add these two vectors, what I'm going to say is, if I call this vector A and call this one vector B, and we do little symbols on the top here to indicate that they're vectors, then my vector math looks like this: A plus B, and what we're going to get is a thing that we call R. Okay, R is called a resultant. Okay, resultant. Okay, so a resultant is our answer. Okay, so quotes, answer. That's usually what it is. It's the result, it's the answer. So in order to do this, we would end up taking either one, it doesn't matter which one. So we have vector A, which was 9, so we go 1, 2, 3, 4, 5, 6, 7, 8, 9. And there's our little arrowhead. And then we add onto it, or we put from head to tail, the next vector, which is 6. 3, 6. So we end up with a resultant now. This is vector A, and we're going to add to it vector B. And so we end up with a resultant that is the total length here. And this is A plus B, which we call R. And therefore, with these numbers, this is just like a number line, and it's very simple. This was 9 plus 6, which means that R is equal to 15, traveling off in this direction, okay, to our right. Very simple. But what happens if we change it a little bit? What if I have, instead, I have my vector, and I'm just going to call these different vectors. Let's say I have vector C, which I will only make this long, and I'm going to make vector C go the other direction, and vector D, and I'm going to make that vector D out here, and I'm going to make it this long in that direction. Okay, so here's vector C, and here's vector D. Vector C here is 1, 2, 3, 4, 5, 6 characters long, and vector D here is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 long. Okay, so there's 10. So what I'm going to do here is the exact same thing. I'm going to have, and I'm going to put the little arrowheads here, and I am going to say that vector C plus vector D equals vector R. I could do it D plus C. It doesn't matter, but I'm going to end up with a vector R here. So if I do this, I'm going to start off with C, which means I'm going to start here, and I'm going to go 6 back. So 2, 4, 6. I'm going to the left. Well, then I'm going to take vector D, and I'm going to place that head to tail. So the tail of D is going to go right onto the head of A, and I'm going to go back the other direction. That's 6, 7, 8, 9, and 10. Okay. And with this, I end up with 6 here and 10 here. And I'm going to add them. But I got to establish which one of these is positive and which one is negative. One thing to remember, in physics, negative means opposite. Okay, so negative means opposite. So if I call 10 positive, if I call going off to the right as positive, then that means going to the left is negative. So that means negative 6 plus 10. Okay, I'm still adding. Okay. So what we tend to do is say that we have 10 minus 6 or plus negative 6. So we can rewrite this just to say that we have 10 plus negative 6. Okay, and that's saying the exact same thing. So here I'm going to end up with my final vector, my resultant vector, is going to be right here. And this is all in the same line, so we call this linear. And so since we're doing this all in the same line, we can use the graph paper and it makes it all nice and pretty for us. So we end up with our resultant R is equal to 4. Very simple. Okay. Thank you. This is just for the first part, linear math, or linear vectors.